Most gardeners are wasting months waiting for compost that never actually becomes finished compost. They pile up kitchen scraps, grass clippings and leaves, turn it once in a while, and then wait 3 to 6 months hoping nature will sort it out. Meanwhile, the pile sits half-rotted, full of pathogens, weed seeds, and unstable organic matter that can actually rob nitrogen from the soil when it's applied too early. The truth is simple. Slow compost usually isn't slow because nature needs time. It's slow because the method is wrong. There's a composting approach, long used in Amish farming communities, that quietly solves this problem. It's not mystical, it's not complicated, and it doesn't require expensive equipment. But it does require understanding how microbial activity actually works. When done correctly, this system produces stable, usable compost in about 14 days. That means instead of building one pile and waiting all season, you can run multiple compost cycles and continuously feed your garden with biologically active soil. One thing I'll mention early for those who want to try the exact setup I use: I've put together a simple compost thermometer and aeration toolkit that helps monitor temperatures and oxygen levels during the process. It's the same type of setup I use when running fast compost in raised beds and soil mixes for hydroponic media blends. If you want to see the exact tools and ratios I use, the link is in the description below. It's nothing fancy, but having a thermometer and proper turning fork makes a big difference when you're trying to hit the microbial temperature window. The reason the Amish-style compost system works so quickly comes down to one principle most gardeners overlook. Microbial balance matters far more than ingredients. You can throw together perfect organic materials, but if the carbon-to-nitrogen ratio is wrong or oxygen is missing, decomposition slows to a crawl. What you're aiming for is roughly a 30-to-1 carbon-to-nitrogen ratio at the start of the pile. That sounds technical, but in real garden terms it's very simple. For every bucket of high nitrogen material like fresh grass clippings, manure or kitchen scraps, you want about 2 to 3 buckets of carbon materials like dried leaves, shredded cardboard or straw. In a typical backyard garden, I build piles roughly 4 feet wide, 4 feet long and about 4 feet high. That size matters. Smaller piles don't retain enough heat, and oversized piles restrict airflow. A pile that size creates the microbial pressure needed for rapid decomposition, and that heat is the secret most gardeners never measure. Within 24 hours, a properly balanced compost pile should reach temperatures between 130 and 150 degrees Fahrenheit. That heat is microbial activity. Billions of bacteria and fungi are consuming organic matter, multiplying rapidly and generating thermal energy as a byproduct. When gardeners say compost takes 6 months, it's usually because their pile never reached those temperatures in the first place. One mistake I see constantly is people adding large chunks of material without chopping or shredding them first. Microbes break down surface area, not volume. A whole cornstalk might take months to break down, but chop it into small pieces and it decomposes in days. The Amish farmers I've worked around rarely throw whole plant residues into piles. Everything gets chopped or broken first. Another critical factor is moisture. The compost pile should feel like a wrung-out sponge. If you squeeze a handful and water drips out, it's too wet. If it feels dry and crumbly, it's too dry. Microbes need moisture to move and digest organic matter, but they also need oxygen. Too much water suffocates the microbial population. The 14-day compost system works because the pile is turned frequently to maintain oxygen levels. This isn't casual turning once every couple weeks. The pile is turned about every 2 days. The first turn usually happens around day 2 or 3 when the center temperature peaks. When you open the pile, you'll see steam rising and the interior materials already starting to darken. And that's when you move the outer materials into the center and the hot core to the outside. This redistribution does 2 things. It ensures all materials experience pathogen-killing temperatures, and it injects fresh oxygen into the microbial environment. Gardeners who are used to passive compost piles are often surprised how aggressive this process feels. But when you're aiming for rapid decomposition, oxygen becomes just as important as nitrogen. In a small backyard garden, this method is surprisingly manageable. I've run 14-day compost piles in spaces smaller than a parking spot. The key is stacking materials properly from the start. A typical pile might start with a layer of straw or dry leaves about 6 inches thick to create airflow at the base. Then a layer of nitrogen material like grass clippings or vegetable scraps. Then another carbon layer like shredded cardboard or dried leaves. You continue layering until the pile reaches about 4 feet high. By the second day, the temperature spike confirms whether the ratios were correct. If the pile struggles to heat, it almost always means one of 3 things. Either there's not enough nitrogen, the materials were too dry, or the pile is too small to retain heat. In raised bed gardening, this fast compost becomes incredibly valuable because it can be integrated directly into soil regeneration cycles. Instead of buying bagged compost every season, you can generate nutrient-rich organic matter continuously from garden waste. I've used 14-day compost to refresh raised beds between crop cycles, particularly when transitioning from heavy feeders like tomatoes into leafy greens. A few inches of fresh, fully finished compost mixed into the topsoil dramatically improves microbial life and nutrient availability. Hydroponic growers can also benefit from this system even though compost isn't directly used in hydroponic reservoirs. Many hydroponic gardeners create compost teas from finished compost to introduce beneficial microbes into root zones or soil-based media systems like cocoa coir blends. A biologically active compost tea made from a properly finished 14-day pile is far more effective than tea brewed from half-decomposed compost. The microbial populations are stronger, more diverse, and far less likely to introduce harmful pathogens. Another advantage of this system is weed seed destruction. Most weed seeds die at temperatures above 140 degrees Fahrenheit. In slow compost piles, temperatures often hover around 100 degrees or less, which means seeds survive and later germinate in your garden beds. In fast compost systems, the sustained heat combined with regular turning ensures nearly every seed is exposed to lethal temperatures. There's also a common misconception that compost must age for months to become stable. That idea comes from slow, unmanaged compost piles that never fully complete microbial decomposition. In a properly managed hot compost system, microbial activity burns through unstable organic compounds quickly. By the end of the 2-week cycle, the material is dark, crumbly, and smells like forest soil. That smell is another indicator experienced gardeners rely on. Finished compost doesn't smell like garbage or manure, it smells earthy, almost sweet, like soil from a healthy forest floor. If the pile smells sour, rotten, or ammonia-like, something went wrong during the process. Usually that means poor oxygen flow or too much nitrogen. Another thing I appreciate about this Amish-style system is how adaptable it is. You don't need livestock manure, though it helps. Kitchen scraps, garden waste, shredded paper, dried leaves, coffee grounds, and even sawdust can all be incorporated if the carbon and nitrogen balance stays within range. Even suburban gardeners with limited yard waste can build effective piles by combining food scraps with leaf collections in autumn. And once you understand the microbial mechanics behind fast composting, it becomes easier to troubleshoot problems. Instead of guessing why a pile isn't breaking down, you start reading temperature, moisture, smell, and texture as signals. One thing worth mentioning is that fast composting does require a little more physical effort. Turning a pile every 2 days is real work, but the trade-off is enormous. Instead of waiting half a year for compost, you can produce multiple batches in the same time frame. For gardeners trying to build soil fertility quickly, that time difference is huge. I've used this method to rehabilitate depleted garden beds where the soil had been overworked for years. By adding several cycles of fast compost over a single growing season, the soil structure changed dramatically. Earthworm populations increased, water retention improved, and crop yields nearly doubled in some beds. So when people ask why this method isn't widely taught in beginner gardening guides, the answer is probably because it requires understanding biology instead of just dumping scraps in a pile and hoping for the best. But once you've run a few fast compost cycles yourself, it becomes obvious why experienced growers rely on it. The garden stops being a place where waste accumulates and becomes a closed nutrient loop. Plant waste feeds microbes, microbes build compost, compost feeds soil, and soil feeds the next generation of crops. And that cycle can happen far faster than most people realize. If you're serious about producing better soil and better food, learning to control compost biology is one of the most valuable skills you can develop as a gardener. If this video helped you understand how real compost systems actually work, subscribe to Iron Age Instincts for more practical growing methods that most gardening channels never cover. And share this video with someone who's still waiting 6 months for compost that should have been finished in 2 weeks.